So welcome. Thank you for coming for this session. So as she said, my name is Angelo. I'm sorry for speaking English. I speak some Spanish, but I think you are in good hands. Better hands with my English than my Spanish. I am Brazilian, by the way. So the idea for this session is to talk a little bit about data lakes. So just to set expectations, today this session is technical, but it's not dive deep. So we are not going to dive deep, technically speaking. So even if you're not a technical person, you can understand what we are going to be discussing today, okay? So the idea is to talk a little bit about what is a data lake and how do we build data lakes on AWS. So before we get started, I'm going to do some questions. So first question is, who works for govern, like public sector, governmental organizations? Who works for educational organizations? Who works in the private sector? Okay, great. So next question. Who are the technical people in the room? Let me see, you have some. Yes, we have some. If you're technical, can you write a SQL statement? Do you use SQL in your daily activities or use it in the past? Yes. Who wrote Python code in your, so we have some people as well. Okay, we are going to talk about all those topics today. Great. So in the past, this used to be how we used to deal with data, right? So this looks familiar for many of you guys. So this is traditional data warehouse architecture. So this is, basically, we used to get data from our databases, relational databases, such as CRMs, ERPs, upload all these data to a big data warehouse, plug some business intelligence tools, and then start extracting information from it, right? So this model still works, right? But the world is changing. So data is growing day by day. So data no longer fits on that model. So because of that, we need a new model so we can accommodate new types of data, not just structured data. We might use some unstructured data as well, such as images, movies, pictures from cameras, anything we want to create to make the life of the citizens better, for instance, in a city. So different data needs a different model. And data is growing as well. So if data is growing, the costs to process and store and process all this data is also growing. So also we need something that makes more sense in terms of costs. And then we have different architectures coming. Also, we have different workloads coming and happening, right? So we used to have business users accessing data. Now we have data scientists. We have different applications trying to share data. We have more people trying to do analysis on top of the data. And SQL is just not enough. So now we want to run machine learning, scientific algorithms. We want to process data in real time, not only in batch, right? Not process all the data at the same time or at night. We want to process the data as the data arrives in a few situations. And there's also a balance in terms of how we are going to handle data in terms of governance, because we have to keep data secure. We have to control who is going to access the data, right? But at the same time, we want to be more democratic. We want to share the data inside of organization. So we have more people accessing the data. We can innovate more, right? So that's a balance. And you have to take care of this as well. So now there's a game changer, right, for this. So there are the data lakes in the cloud. So how this works, basically on AWS, and I'm going to talk more about this, right? So we get all the data, we put into a storage, right? And this is a very high-level architecture of a data lake. And we have this central storage. And then we start using services, different services for different situations to try to ingest data. We can ingest data all at once, like using, for people who were here before, we had a Snowball here. It's a big storage. So you can copy the data to storage, send to the AWS. This is a service called Snowball. And then we are going to ingest the data into your data lake, right? And also, once the data is uploaded or ingested, then you can start to plug different services to analyze that data, right? It's not only SQL. You can use different approaches, like machine learning, and different engines to process all this data. So the architecture has changed, right? So this is a high-level architecture, and we're going to explore it more. But at the end, what is a data lake? What is the definition of a data lake, right? So basically, to be very simple and clear on that. So first, data lake is centralized. So you're going to put all the storage in the same place. So the storage is going to be close to each other. So you can start joining data from different sources at the same location. Also, a data lake is secure. You can encrypt that data and control exactly who is going to access the data lake, right? So we have governance. So you can discover data and start sharing data with different companies, different customers, different organizations within your company or your organization in a very easy way. And at the end, you can analyze all this data. Doesn't matter if the data is structured or unstructured, right? So you can work with tabular data that comes from a relational database, or you can process a video or an image, right? And we have many different customers already running data lakes on AWS. So in the United States, we have NASDAQ, you have FINRA, you have Ticketmaster, you have Pfizer, Discovery Channel, you have Philips, and many others, right? So who here knows the game, a game called Fortnite? Maybe you don't know, but your children, your sons, they know. So it's probably the most popular game, right? And it runs on AWS, and the data lake runs on AWS. They have petabytes of data. Well, so let's start talking a little bit more about that architecture, the high-level architecture. So where we start, if you want to create a data lake, where is the starting point? Is the storage, right? So I have to set this storage. And this is the main difference from traditional architecture. So on AWS, we use a service called S3. So S3 is an object storage. It has a lot of advantages. First, it's very, very cost-effective. Comparing to traditional storage, is very, very cost-effective. All right, so you can get started using one tier, and if you don't need the data or you think you're not going to process the data, you can move it to a different tier and pay even less. So this is the first advantage. The other point is you can ingest data on S3 using many different ways, right? You don't have to think about scale. Oh, I'm going to buy 1 terabyte or 1 petabyte. No, you don't need it. You just pay what you use. So if you ingest data on S3, you're going to pay exactly the amount of data that ingested. So let's see, 1 gigabyte, you're going to pay for 1 gigabyte. So second month, you ingest 1 terabyte, you're going to pay 1 terabyte. And by the way, in Virginia region, which I believe is one of the closest regions to Mexico, 1 terabyte of S3, I think, costs like $22 or $24, but can go down to $1 per terabyte of data. Those prices changes. but this is more or less the current price. So it's very, very cost effective to use S3 as a storage. You can have many people working on top of this storage because it scales in terms of performance, so you won't see a bottleneck, right? And you can plug different engines, different applications running on top of S3, accessing the data from S3 in order to process all this data. So very, very flexible. Here, I'm going to share some different ways to ingest data to S3. So the first one is a service called AWS Glue. This is our service for ETL. Second one, AWS DMS, where we can connect to a relational database, keep track of the changes, and then upload the data to S3. You can use our favorite ETL tool if you have some ETL tool running on premises. You can install it on EC2 running on AWS. And there are different services as AWS Transfer for SFTP, if you want to use secure FTP, or Storage Gateway. And there are many other ways to ingest data, right? Well, so we talked about storage. This is the foundation, right? But we need more in order to build a data lake. So second point is ETL. So we want to ingest data, we want to transform data, and we want to extract data from some source. That could be a database or something else, right? So we have a service called AWS Glue. AWS Glue is serverless. It means you don't have to manage infrastructure, right? We just pay for the jobs that are running. And this is really also really cost effective because let's suppose you run your jobs in during 4 hours every night. So you're going to pay for 4 hours of compute, right? So this is a great advantage. You don't waste infrastructure that won't be doing any processing. So this is how AWS Glue works. So some components of Glue. Glue has a data catalog. So you can extract the metadata of your tables, right? And Glue is going to manage that. Glue is serverless, as I said. And Glue also can orchestrate your jobs. You can create workflows and connect jobs to be executed. Okay, so we talked about where to store the data, right? Data is on S3. Where to analyze the data, where to do ETL, which is Glue. Next topic is analytics, or how to analyze our data. So also we have many different options. I will start talking about Redshift, right? So Redshift was born as a modern data warehouse solution, right? So it's basically a full database. You have full support for relational data, store procedures, views. You can use transactions. You can insert, delete, update data, right? So pretty much as relational databases do. But Redshift uses modern architecture. It scales horizontally, as you can see here. So basically, this is the vision of the user. You're going to connect into one endpoint, as you do today with your regular and traditional databases. But after that, there's a whole architecture that can scale horizontally. So in this example here, we have 3 nodes in the cluster doing the processing. So the first node, you connect. The other nodes, they do processing on top of the data. And you can start with one node. You can because you have less data, and once you get more data, you can start raising your cluster, 2, 3, 4, 10 instances, 10 different nodes, and then you get more storage, more processing power. So this is how Redshift was born, but then it evolved, right? So Redshift can also integrate with your data lake. So remember that I said that usually the data lake data will be on S3. So Redshift has its own storage that is on the compute nodes, but you can also connect this to the data that is on in the data lake on S3. So this is called Redshift Spectrum, right? So have a data warehouse, and the data warehouse can access the data also from the data lake. So we call this architecture a lake house architecture, because you have the best of two worlds, right? But let's suppose you want to do SQL on the data. You have structured data in your data lake, but you don't need a full database, right? So we have a very good solution called Athena. Athena, you can also run SQL on top, directly on top of the database. Sorry, on top of S3, right? So on Athena, you don't have full support for transactions, for instance, as you have in Redshift, but it can scale. So you can have like a lot of data in your data lake, and Athena will process all this data for you. So a simpler approach, right? But a very, very scalable service. The technologies behind Athena are Hive and Presto. They are open source technologies, right? That we use to build this service. Okay, so I talked about Redshift, full database, and I talked about Athena, a query service, very scalable, right? We have another option called EMR. So EMR is the Hadoop ecosystem running in a cluster. So let's suppose you need more than SQL, right? You want to write Python code, you want to write Java code, you want to use different frameworks. So EMR has more than 20 frameworks that you can use to process data. So a lot of flexibility here. So using EMR, you can create scripts, batch, or real-time, right? You can use machine learning. You can run a NoSQL database. And you can run SQL here as well. We have the same technology that we use it to build Athena, which is Presto, and Hive. You can run it here as well. And here you have more flexibility. You can install new software. You have full control over the cluster that is running EMR. So more flexible solution. Let's suppose we want to ingest data. So we have a whole family of services called Kinesis. So here I'm going to talk about Kinesis data streams. So basically Kinesis data streams, you can ingest data in real time, right? And get this data and then process in real time as well. So Kinesis has different services, such as Kinesis Analytics, where you can use SQL or Java to process the data in real time. So let's suppose you are getting data from traffic from all over the city, and you want to process as the data arrives. So Kinesis is a good service, a good solution for that. Great. So we talked about a lot of different analytical engines, right? And by the way, you don't have to use it all. Every data lake architecture is unique. So you can use the service that makes sense for you. You don't have to use it everything I'm saying here. So that's why I said that data lakes are very flexible. You can start small and start using the services that make sense for you as they make sense for you, right? So let's suppose you want to run machine learning on top of this data. We have a lot of services as well, right? So here we have some stacks of services. The first one at the base is infrastructure. Well, so let's suppose you have a lot of very skilled engineers. They are experts in machine learning, and they don't care about managing the infrastructure. So they can use this. So we have images of virtual machines pre-installed with the main frameworks, open source frameworks for machine learning. You can start a virtual machine and start processing our data. So this is how this stack works. But let's suppose your team is just getting started with machine learning, right? So on top, we have our AI services. They are APIs where you don't need to be an expert in machine learning to get started, right? So for instance, if you want to do image recognition, right? So we have a service called Recognition Image. So you upload an image, and it will give you a lot of insights about this image. Is it a person, is a man or a woman? Is he smiling or she smiling? Right, so different insights. And again, you don't need to be an expert on machine learning because we wrote the model for you. Right? Another examples, you can use Amazon Comprehend to do sentiment analysis from documents, right, and help you to analyze the content of documents. So many different services on this top layer, right? So we keep adding more APIs. They are great for people who doesn't have experience in machine learning, but also even the experienced people, they can use it, right? Because they are very good models. We keep constantly updating those models so they can work better. So the last layer is Amazon SageMaker, which is on the middle, the machine learning platform. So if your team has more knowledge about machine learning, they can use this platform. And here, they don't have to worry about infrastructure provisioning. So the service will take care of this for your engineers, right? So also a service for experts, but and people who are starting with machine learning, has people who have some knowledge about machine learning, but here they don't have to worry about the infrastructure. So 3 different layers for our customers. So SageMaker has a lot of functionality. I will not talk about everything here, but here are some of the functionalities that we launched the end of the 2019. So we keep innovating and adding more functionality to the service. I can talk about, for instance, about SageMaker Studio. SageMaker Studio is an IDE for machine learning. Has a lot of good functionality that integrates with SageMaker native functionality, right? Also, we launched last year SageMaker Autopilot. So again, let's suppose you want help to build your models. So you just tell SageMaker what you want to do, and SageMaker will generate the code for you, right? And then, of course, once it generates the code, you can tune, you can write it, you can change it, you can change your code, and then get better results. Great. So this sounds kind of complicated, right? I'm talking about a lot of services. And in 5 minutes, I'm going to do a quick demo to create a new data lake so you can see how it works. So don't worry, right? But oh no, can you go back, please, to the presentation? Thank you. So we launched a service called Lake Formation. So the idea behind Lake Formation is a service where you don't pay for using it, right? So basically, Lake Formation will configure your data lake for you, and then you pay for the resources used by the data lake. But we don't charge for this. So basically, Lake Formation is going to help you to set up your data lake, to ingest the data, and to keep it secure, right? Then you can enforce access and create different users and databases and specify in a very easy way how and who can access your data, right? So this tool is just to keep it simple, just to help the customers to configure their data lakes. Great. So now we talk about the basics. Then I'm going to do the demo for you. All right? So can you please switch? Great. Thank you. Okay, so this is the AWS console. Basically here you can get access to all our services, right? And create a data lake or any other architecture. So let's get started by configuring the storage. So this is the S3, right, console. And first thing I'm gonna do to my data lake is to create a bucket. So the bucket is like, is a definition of your storage, a logical definition of your storage, right? So once you create a bucket, you can start configuring access, for instance, like who can access the data. So this bucket is going to be named MX Summit. And that's it. So just give it a name. Of course, there are many other options here, right? But just to keep it simple, I just creating a simple bucket and giving the bucket a name. So now I can see the bucket here. Let me see something. Yeah. So here you can see the bucket, right? And I'm going to click on the bucket. And then you can see the bucket is empty, doesn't have any data, right? So I can start creating some folders. So I need a folder for my scripts and my libraries, right? Because I'm going to upload some scripts to process data. And that's it for now. I have my bucket, right? I will start filling the bucket with data as we go through the presentation. So the first step of our data lake is done. We have the storage set, right? So next step is to ingest data. Many different ways to do it. I'm going to use Glue, which is our ETL tool, right? So let's go to Glue. So I type Glue here, and that's it. Okay, so here I have Glue. So I can create jobs, workflows. I can create databases. Right? So first thing, I'm going to create a database. It's going to be called MX Summit 3. So let me check these names, MX Summit 3 and MX Summit 3, okay. So I have a database, which is just a metadata. This is the data catalog, right? And that's it. Now I'm going to create a job. Of course, I have created this script. I have a Python script here that I wrote previously, right? In fact, Glue can create simple scripts for you. So if you want to just ingest data, Glue can create the script for you. So you create a connection to a database, and then you can ask Glue to create a script. In this case, my script goes beyond just ingestion. So we are going to do some ETL. Basically, we are going to upload data from two different tables. Those tables are already extracted as CSV files, right? We are going to load all this data into the memory, and we are going to join this table, do a query, and create a third table. So we are going to ingest two tables, but create a third one using a join between those two tables. So typical ETL job, right? And Glue supports Python as a language, and also Spark. Spark is a library where you can process huge amounts of data in parallel, right? So you can scale pretty well, right? But if you don't need this amount of scalability, you can use simpler scripts using just pure Python, which is what I did here. So this is my script. Probably you can read it. Let me see. Let me go here. Okay. So the only thing I have to change here is to put the name of my bucket. All the other parameters, I don't have to change it, right? So basically, this is what this script is doing. I download two files from the internet. This is a public data set where we have movies and rates of the movies. So people can vote, and then we see which ones are the best movies, right? So I download those 2 files, load it into the memory. I join those 2 files, which are tables, and create a third table. So this is what this script is doing. And by the way, I have a video here of the demo. So if you run out of time or some things go wrong with the internet, I can change to the video. But let's try to do the live demo for now. OK, so first thing here, I'm going to create a job. So I go here. I click Add Job. I give the name MX Summit 3. I use a security role to get that allow me to access that data. And I'm going to use Python shell. I don't need Spark for now, right? So that's it. I'm going to provide a script. And before that, I'm going to upload my script. So I go here to S3. I upload the script. My script is here. It's called ETL with pandas. For the Python programmers, who knows what pandas is? So pandas is a very popular library among the data scientists, right? So we have a lot of good functions you can use to process data, to join data, and this kind of thing. Second thing I'm going to do is to upload a library, because I have some, for instance, pandas, right? It's here on this file. OK, so I uploaded 2 files. They are my scripts, right? Great. So now I can go back to Glue and create a script. So I'm going to click here and say, OK, this is the script I want to run. So the script is ETL with pandas. Select. And then next step is to select the Python library path. So with my library. So the library will be here in the lib, Glue Python, and that's it. I can configure the capacity as well. So here, we are going to allocate 1 gigabyte of memory and 1/4 of 1 CPU, right? Because we want to pay less. And we don't need a lot of compute capacity for this. So I think that's it. So I'm going to save the job. I can see here, right, the script, so MX Summit 3. And I think I don't have to change anything else. So I can go back. And then I'm going to see the script here. Where are my jobs? So now I see my script. So MX Summit 3, action, run job. Great. So I'm going to create here. I'm going to click here. And then we can see here the script, if the script is running. So it has the status running. So usually this takes like 1 minute to run. So let's wait and see. Sometimes it takes more, right? Because it has to download data from the internet. Might be some variation in the internet. So let's wait, right? But while we wait, basically what this script is doing right now. So Glue allocated some compute capacity for us, right? 1 gigabyte of memory is not a lot. And then it started to run my Python script. So my Python script first is going to download those 2 files from the internet. And then it's going to write the files to S3. Then it's going to join the data. Here I'm running 1 million votes. So it's a lot of data, but it fits on the memory. But let's suppose I'm going to process much more data. In this case, I might have to use more compute capacity. But for here, it's good enough. Then it's going to join the data, create a third table, and write all those 3 tables to S3. And then after it finishes, if anything goes well, we are going to go to S3, and we'll see the data there. 3 new folders, 3 or more new files. Okay, so it's finished. So I can see succeed here. So let me show you. So status, succeeded, right? So it means no errors happen. So let's go to S3. Remember S3, here we have 2 folders, lib and scripts. Let me refresh this. And now I have a new folder called data. So we have data, right? Let's click it. So we have process, so process data. And then we have 3 folders. Best movies, movies, and ratings. So movies and ratings are the 2 tables that I downloaded. Best movies is the join between those 2 tables. Okay? So basically here we have data in a format called Parquet. So Parquet is open source, is an open format for data. Very, very efficient for analytics. So it's compressed and it's columnar, right? So you can run your analysis here. Great. So now, next step, I need to crawl this data and create tables from it because they're not tables yet. I cannot do SQL. So I'm going back to Glue, and then I go here to the crawlers, and I add a crawler. So the crawler name is going to be the same, MXSum3, and I specify a path. The path is going to be the bucket that I created at the processed folder. And next, I use the security role so it can give me access to the data. Next, I choose a database where I'm going to create a table. So the database is MXSum3, and next, and finish, and run. Okay, and it's running. So again, this should take 1 minute, maybe more. Now that I have 2 jobs, right? The first job processes the data, the second job finds data and create tables from it, right? And so now I can create a workflow. I won't be doing this, right? Because we have limited time. But once I have these jobs, I can create workflows. Glue will handle that for me. Some customers, they use Glue workflows, but you can, if you have your favorite workflow tool, you can check if it supports Glue, and then you can integrate with different workflow tools as well. Let me see here. Oh, finish. Okay, so here we have the MXSum3, right, database. So now we can start doing some SQL on top of this data, right? So let's open a new service, Athena, to see if the tables are showing there. So here, let me zoom. So here we have the database MXSum3, and we have 3 new tables: best movies, movies, and ratings, right? Great. So now, if I go here, right, I can do a query and try to understand which are the most voted movies. Basically here, I'm connected to Athena, and I'm running a query against my data in the data lake, right? So probably you cannot read it. I'm going to zoom. But here, the best movie of all times, according to this database, is Shawshank Redemption, right? Has the biggest vote. And if you don't know this title, in Spanish, here in Mexico, this movie is known as Sueños de Libertad or Sueño de Fuga. There are 2 names. Who knows this movie? Yeah, it's my favorite movie. So it's really, really good. And as you can see, I run this query, right, in less than 4 seconds, processing more than 1 million of rows. I'm joining. Basically, this query is the same that I did in my script, right? So I'm joining those 2 tables and counting the votes to understand which movie is the most voted. Okay. So now that we have the data, I can go back here, right? So we have this story. We ingested the data. We processed the data. We analyzed the data. we started getting some answers, like which one is the most voted movie, right? So we processed more than 1 million votes in less than 4 seconds, right? Now I can start connecting visualization tool, right? So if you use some tool, you can check the compatibility and then install it and use it. But we have our own. So let's check QuickSight. Great. So here I can create a new data set, right? And then I can choose like S3, MySQL, many different databases, Aurora, RDS, right? In this case, I'm going to connect to Athena. Then I put a name for my data source. So it's going to be Mexico Summit 3. I validate the connection. Oh, and I create a data source. But before that, let me do something. I'm going to add security, a permission to access that database or that bucket, because I don't have access to it. So I go here to S3, right? I select all, finish, and then this is going to give me access to all those buckets, and then I can access the data. That's it. So let's go again, manage the data, and create a new data set to Athena. I give the same name, and I create a data source. I select the database, MX Summit 3, and the best movies. I can import to the memory, or I can access the data directly. So I'm not going to import, because I don't want to wait. That's it. Here I can create some fields, right? And it will start querying the data. It's going to take some time, and show a graphic, right? So it's here. I can see the same view that I showed you guys in the SQL. I can see here, right? So Shawshank Redemption is the most voted movie in this particular public data set, right? So basically we took how much? 15 minutes, maybe 20 minutes, and we created a very simple data lake, right? So we created storage, we ingested data, we processed data, we joined data together, we created tables, then we create a simple visualization on top of this table, and we run some SQL queries, right? So in 15 minutes. So this is the power of the cloud, right? And here we are dealing with 1 million rows, but we could use billions of rows, because all of this is scalable. Okay. Can you go back to the slides, please? So we have a few more minutes, so we can wrap it up. Good. So let's talk a little bit, before we finish, about open data and why this is important, right? So the idea behind this program called Open Data is to give access to data that is public, right? So if you work for government and you have interest in publish your data, you can do it. You can copy to AWS. You're going to publish, and people can, other customers, they can get access to this data and start innovating on top of this data. So let's suppose you don't have the resources, or you don't have the time to process data now. So you upload this data, and then anyone can work on top of this data. Of course, here we are talking about public data sets, right? So this is why this is important. So we have this program. You can access here the URL, opendata.aws, right? And how this works? So basically, we're going to upload the data, usually to S3. We give access to S3, and instead of the customers, they download the data, they don't need to download the data because the data is already on AWS. So they can upload their codes to AWS and process the data close to the data. They don't have to download it, right? So this makes all this process of sharing data and processing data much more simpler. So that's the idea, right? So on the left, you see the traditional way of sharing and processing data. On the right, you see AWS way. Upload to S3, any customer can of course, if you upload to a public data set, any customer can get access to it and process on AWS without leaving the data from AWS. So that's the idea. So if you want to access and search for public data sets, just go here, and then you can search and find some good data sets that you might want to process. If you want to share your data, if you want to participate on this open data, talk to us. We can talk to the right people and try to evaluate the situation. If you have interest in learning more about everything that I said here, we have on AWS, we have a lot of different trainings. So we have free online training. We have presential training as well. So you can talk to us, right, and train yourself. We have trainings about analytics, databases, machine learning, and much more. Don't forget to access I'm going to back here, let me see. So there's my email. If you want to talk to me, just drop me an email, we can start talking, right? And don't forget to fill the evaluation, okay? And if you have any questions, I will be here, we can talk. Thank you very much.